Okay, this is in section 4.2 where we're doing division of polynomials, and let's look at number 3 where it says here's a polynomial, and if you divide it by the quantity x minus 3 you will get x minus 1 remainder 4. Let's check the arithmetic. Okay, so this is a good chance to review going through the long division. So I'm going to take my divisor, put it outside, and then my dividend. And remember, the first thing we're going to ask ourselves is what times x will give me x squared? And in this case, it's x. And then you multiply that first part of the quotient by each piece of the divisor to get x squared minus 3x. And then subtract. So the goal was to get rid of that first term x squared, which I'm going to do because that's going to cancel out. And then I'm going to be left with minus x and then bring down the plus 7. And let's do the process again. What times x will give me negative x? Well, that will be negative 1. And when I multiply negative 1 times the divisor, I get negative x plus 3. And remember, subtract. And the x's cancel as they should, and I'm left with a remainder of 4. So yes, this is the case. And remember what we're doing when we divide. What we just did is I said x squared minus 4x plus 7, which was my polynomial. When I divided by x minus 3, I got my quotient of x minus 1 plus my remainder over the divisor. Now, if I multiply both sides by x minus 3, I'm going to get a new way to write my polynomial. So again, if I multiply both sides by x minus 3, I'm going to get my polynomial, which is x squared minus 4x plus 7, is going to equal x minus 3 times x minus 1 plus the remainder. So in other words, this is what I've gotten here. My polynomial equals my divisor times my quotient plus my remainder. Okay, and for similar situation, and you're going to perform the division and then write like we did in the previous example, part B. And let's now go to looking at the next page. So one thing to be concerned about, or just to be vigilant about when you do long division of polynomials, in order to make things line up properly, you want to make sure that if you're missing a degree, whether that's in the dividend or the divisor, that you put in a placeholder there. So here's what I mean. So notice when I'm looking at my dividend here, I have a 4th degree, I've got a 3rd degree, then I've got a 2nd degree, a 1st degree, and the 0 degree, which is my constant term. So all good there. But my divisor is 3x squared minus 2. So I don't have a linear term. So to make sure that things line up properly, I'm going to just put 0x for that linear term, minus 2. So that's what I mean by putting in a placeholder. Just put 0 times whatever degree it is, just so things end up lining up properly. Let's go through the division here. Okay, just so I can show you that is, the 0x isn't going to negatively impact it. It will just make things line up nicely. We ask ourselves what times 3x squared will get us 6x to the 4th, and that will be 2x squared. And then multiply that times every piece of the divisor. So I'm going to get 6x to the 4th plus 0x cubed, because 0 times 2 is 0 times anything is going to be 0, and minus 4x squared, and then we're going to subtract. And so we get 9x cubed is left over, and then plus 6x squared, and then bring down the negative 8x. And again, go through it again. You ask yourself, what times 3x squared will get me 9x cubed, and so on. Okay, and so 6 and 7, similar types of problems, just practicing your long division and then rewriting the polynomial as the quotient times the divisor plus the remainder. Okay, well, luckily, we don't always have to use this long division. There is a shortcut called synthetic division, but you can only use this shortcut when the divisor is of the form x minus some constant or x plus some constant. So it has to be of the form x minus c, or x minus k sometimes is used. Either way, x minus, so it just means x plus or minus some sort of constant. And of course, if c is negative, this would be x plus. All right, so again, it has to be of that form. And when you see the algorithm, you're gonna see why that's the case. So let's actually first, in order to get a hang of the algorithm and see why it makes sense, let's first do long division here. And I'm gonna put in a different color the parts of the problem that are important, because you'll notice with long division, or maybe you've already noticed, that it can be pretty redundant. You're doing kind of the same steps over and over again, and they're just important numbers throughout that are unique to a given problem. Otherwise, we're doing redundant things. Okay, so let me start. I'm going to put in red the important, actually, no, maybe, yeah, I'll put in red the important pieces. Okay, so let me get started here. We've got, I'm going to just write x cubed. You notice these are less important than the numbers in front. So here are the important pieces. I've got my 2, my minus 6, my minus 9, and the plus 4. And the reason the variable is less important is because I know I'm going to get rid of them one by one. That's the whole goal here when doing this long division, is to eliminate until I get down to either it goes in perfectly or I have some sort of remainder. Okay, again, first things first, I say what times x gets me 2x cubed, because that's what I want to eliminate first. Well, that's going to be 2x squared. So that 2 up there is important, x squared. Okay, and then I am going to subtract. Sorry. First, I have to multiply by the divisor, and then I can subtract. So when I multiply, I get 2x cubed minus, well, actually this piece is going to be important, minus 4. Okay, minus 4x squared, and then we're going to subtract. And notice again, I know I keep saying this, but the numbers in red are the unique ones to the problem. And this will help see how the algorithm works when we do this little shortcut. Okay, so when we subtract the x cubed, as we hoped, that was the goal, that's going to go away. And I'm going to be left with negative 2x squared minus, and I'm going to bring down this, minus 9x, okay? And then we go back to asking ourselves what times x gets us negative 2x squared, and that's going to be negative 2x. Then we multiply, and we're going to get negative 2x squared, and I'm going to get plus 4x. Then we're going to subtract, and we're left with, let's see, when I subtract, I get minus 13x. And let's bring down the plus 4. And one more round here. So ask ourselves, what times x gives me negative 13x? And that's going to be negative 13. We're going to multiply, and we're going to get negative 13x plus 26, then subtract, and we're left with this remainder of negative 22. Okay, so let's keep this in mind with when I show you this algorithm. Again, the only way to use this shortcut, the divisor has to be of the form x minus c. Because we need the dividend of, we need the coefficient of the leading coefficient of the dividend and the quotient to be the same. So notice here, in order for this algorithm to work, these two have got to be the same. And the only way that's the case is if I'm dividing by x minus or x plus something. Okay, so here's the algorithm. First thing I'm going to do is I'm going to, remember, it has to be of the form x minus c. So I'm going to put my c on the outside. So my c in this case is 2. And then I'm going to put the coefficients, and if there's a missing degree, you've got to put a 0. So the coefficients in descending order of my dividend. So in this case, I've got 2, -6, -9, and 4. And the first step in this algorithm is to bring down that first leading coefficient. Bring down the 2. Okay. And then we're going to multiply like we did before. So 2 times 2 is 4. But instead of subtracting, we're going to add here. Now notice, because I'm not doing -2 here, because I'm doing 2, instead of subtracting each time, we're going to be adding. So -6 plus 4 is going to give me -2. Then I'm going to do it over again. -2 times 2, multiply, get -4, and add. -13. Again, multiply, -13 times 2, -26, and add -22. This last number is always your remainder. And what I have left, these pieces here, are the coefficients of my quotient. So since I divided a third degree by a first degree, I should be left with a second degree, or a quadratic. So I'm left with 2x squared. So my quotient is 2x squared minus 2x minus 13. And my remainder was -22. So I can rewrite now this polynomial as 2x cubed minus 6x squared minus 9x plus 4 equals my divisor times my quotient minus, plus my remainder, which happens to be minus 22. Okay, so that's a shortcut. Again, super helpful and easy to use when the divisors of the form x minus c. All right, now we're going to get into generalizing something in the next video related to all this. So it's going to be a little bit theoretical, but that's up next.